So the concept of a mole is important. Mole is equal to 6.022 times 10 to the 23rd of anything. So it's important in chemistry to count things, atoms and molecules. It's also important in chemistry to be able to weigh things on a normal scale. So it would be hard to weigh an atom on a scale, but it's not too hard to weigh a mole of atoms on a scale. Specifically then, that brings us to something called molar mass. It's the mass of 1 mole. Mass of 1 mole of anything. So the molar mass Molar mass then is grams per 1 mole. So we're going to talk here in a minute what it is for the elements right here. This is so cool. So we talked about the periodic table as a way of organizing the elements, and actually there's a pattern into why the periodic table as it is, and they line up what? By a column, right? We call those groups or families. But in the periodic table for each element we have the whole number. Okay, I'll pull up carbon here. Symbol for carbon, of course, is 12. We have the whole number. That is what? The number of protons. And then we have the decimal number. And on periodic tables for carbon, you will find that that is 12.01. And we talked about how that number actually is how much a carbon atom would weigh in units of what? AMUs. Right? Okay, is that ringing any bells? I call that the decimal number. And with regard to the molar mass, scaling it up from something very small to something we can sink our teeth into. This decimal number is also the molar mass. So in other words, picking on carbon, if you wanted, here's my little scale here, here's my carbon atoms. If I wanted to have 1 mole of atoms, I would go and make sure I weighed out 12.01 grams of carbon. Does that make sense? So we say the molar mass, and this is, we picked on carbon, could it be, but it could be anything. The molar mass of carbon is equal to 12.01 grams carbon per 1 mole of carbon. And kind of throw on that top of that, make sure we're on the same page. That 1 mole is 6.022 times 10 to the 23rd carbon atoms. Does that make sense? So molar mass for the elements. You just pick it off of the periodic table. It's wonderful. All right, so what if carbon is bonded to something else, like carbon dioxide? Well, I believe we talked in an earlier thing where carbon dioxide, if you wanted to know how much that weighed, mass, okay, you could actually use the periodic table. I'll just put P table. And what you did is you looked up how much carbon weighs, and then you added that to how much oxygen, 1 oxygen weighs times 2. Okay, you got the mass. Well, I'm here to tell you then, and that was in atomic mass units or U's. I'm here to tell you that that same mass that you got from the periodic table by adding those individual masses, that is the molar mass of carbon dioxide, which I can't think of right now. I should be able to, 44.01 I think, molar mass of CO2, okay, is the same thing as how much it weighs in atomic mass units, but the molar mass will be grams per 1 mole. All right. So sticking with the elements, then we've got some pretty elements. We have copper. Each one of these chunks of elements represent 1 mole for that element. So we have copper. Then somebody had to weigh out 63.55 grams of copper to get 1 mole of copper atoms. Now, if you look at the decimal number for copper, it's 63.55. Aluminum, the decimal number is 26.90. Its molar mass is 26.90 grams per mole. Lead, 207.2 grams. Sulfur, 32.07 grams. These have different densities, don't they? Because some are fluffier and some look more compact. 24.31 grams. And 52.0, sorry, for magnesium, 24.31 grams. For chromium, 52.0 grams. So just so we're all on the same page again, okay, All of these numbers came from the periodic table, okay? And they are how much it weighs in AMUs for one atom of that element, and they are also the molar masses for the element. So let's pick on sulfur. Okay, so for sulfur, that decimal number 32.07 grams in this exercise, I'm saying 32.07 grams of sulfur is 1 mole of sulfur. That's it. Okay. So let's do 2 together, and now all you got to do, and does this seem like a valid test question? I think so. What's the molar mass for these elements? Remember, you are going to have a periodic table. So krypton, I need to find krypton on the periodic table. The decimal number for krypton is 83.80. Now, one of the things in this problem is you need to know the units of molar mass are what? Grams for 1 mole. And it varies for each element, right? So let's look at iron. The decimal number for iron is 55.85. Okay, so 55.85 grams of Fe for 1 mole of Fe atoms. Let me go ahead and make this a little bit better up here. Does that make sense? All right, so quick video quiz. So what are the molar masses of manganese, not magnesium, manganese, Mn, and helium?